This is Preethi here. Today I am again here with you to say one of the topic from one of first year engineering chemistry. Today I am going to teach you about unit 4 from engineering chemistry first year, that is organic reactions and drug molecule. That means today we are going to talk about the organic reactions and some of the drug molecular reactions, which is a unit 4 in the first year chemistry of engineering. So under this there are few topics which I am going to discuss, which are important, and I'll take you through the brief of that particular topics. Okay, first topic what we are going to discuss is about types of reactions, types of reagents, that is electrophilic and nucleophilic reagents. Okay, so what is meant by an electrophilic reagent? Electrophilic reagent is nothing but where all electron deficient atoms or a group of atoms is known as a electrophilic agents. Okay, where the electrophilic attack at the electron rich center will takes place. Okay, so what happens here? All the positively charged ions or positively charged species are called to be electrophilic, and the components in which the octet of central atom is not complete. Means we all know that any of the compound to attain stability, it should have an octet rule. Okay, when the component in which the octet of the central atom is not complete, that all comes under with this electrophilic reagents. Okay, the next thing is all the components in which the central atom can expand it octet rule or octet structure. For example, we say BF3, AlCl3, ZnCl2, etc. Okay, and now what is nucleophilic? Nucleophilic reagent is nothing but all the electron rich components are nucleophilic and it get attacks with the electron deficient center, whereas in electrophilic it is electron rich. Okay, the central atom will be with the electron rich center, whereas in the nucleophilic we have electron deficient center. Okay, where all the negatively charged species will get attack over nucleophilic reagents, such as examples NO2, Br minus, NO2 minus, Br2 minus, CH3 minus, etc. Where in nucleophilic the components in which the central atom has a lone pair of electrons and all the organic metallic components are nucleophilic reagents. Okay, now what next comes with addition reactions. What is meant by an addition reaction? See, an addition reaction occurs when any of the atoms are added to the given component which is containing with either double bond or with a triple bond. Okay, there are limited components that have this kind of bonds. Okay, for example, see here, electrophilic attack. Okay, so getting with a positively charged ion, whereas now it is a nucleophilic. Now this nucleophilic will get attack over here. Have you got it? Means the electrophilic electron is going to get attached over here by shifting with a double bond, and nucleophilic is going to get attached to the next carbon of the electrophilic. So there is an addition of the electrons at the central atom. So that is said to be an addition reactions. Okay. Now I'll tell you another one. Next we are going to talk about reagents. Or let me take you through the reactions of it. How the reactions proceeds. See, the electrophilic addition is a reaction between the electrophilic and nucleophilic. As we have already discussed about addition reactions, how it is taking place. It is taking place between the electrophilic and nucleophilic reactions. Between these two only the reaction will be carried forwarded, adding with a double bond or with a triple bond. That means, but electrophilic will get added first, okay, then after the unsaturated compounds will be forming with a nucleophilic attack. One example of the reaction I'll show you. This is an example. Ethyl, when the double bond is shifted, what you will get? The hydrogen atom here, CH2H and CH2 plus positive ions. So what will happen here? Br minus, this is what nucleophilic, okay, with a lone pair of electrons will go and attack here. Okay, so what is happening here? CH2H and CH2Br. This is positive and this is negative, as we have got first electrophilic and nucleophilic as the second component. Okay, in place ethyl plus HBr we can take hydrogen plus and Br minus. Now this hydrogen will go and get attack at CH2, we are leaving with one of the bond, and then after nucleophilic attack is going to happen as we have seen here. So it is CH2H and Br2 HBr. Okay, now let me tell you one more. Markov-Nikov's rule. Markov-Nikov rules is nothing but when an unsaturated alkyl substances with an hydrogen halide, okay, the hydrogen get added to the carbon that has a more number of hydrogens, and then to the halogen of the carbon few number of hydrogens. In this, the major product observation is known as the Markov-Nikov rules. Okay, the example in this we will show you. CH2 this is nothing but 2-bromo-propane. Okay, it is a major product which is obtained first. Okay, with this only the second product we will get is 1-bromo, because the bromine is attacked at the first carbon. Here the bromine got attacked to the second carbon, so we say 2-bromo-propane. Propane means 3 carbon atoms with a bromine group attached to the second carbon. So we say 2-bromo-propane. And here bromine is getting attacked over the first carbon, so we say 1-bromo-propane, which is a minor product. So in this, there are the chemical reaction steps, how it is going through process, I will let you know. See, the chemically based of Markov-Nikov rules is formed by the most of stable carbocation during the process of additions. Okay, that is addition process. During this addition process, firstly we get attacked with the hydrogen ions to one of the carbon atom, forming to get a carbocation intermediate. Then after, the more substituents to the carbon cation, the more stability it is. So due to the hyperconjugation, the major product of this is to be added. That is nothing which is more stable and which is having with a more stable intermediates. Okay, so the first step is like a HX and H plus X minus. As we say, H plus could be a electrophilic and X minus could be a nucleophilic reactions. So under this, as we have already discussed, which is less stable and which is more stable, this would be a more stable one, as this would be a very less stable component. Now, anti-Markovnikov rule. What is meant by anti-Markovnikov rules? There is a rule for this. Let me tell you the rule. What is this rule is all about? In presence of peroxide, hydrobromide additions on unsaturated components, then the bromine is added to the less substituent carbon and hydrogen will be added to the more substituent carbon. Okay, this kind of opposite attacks is known as a Markovnikov rules. This is also known as pre-oxide effect. Okay, so in the place of HBr, there could be HCl or hydrogen iodide and hydrogen fluorides or any of these. Okay, now let me tell you the mechanism of it. Addition of HBr to propane. Addition of HBr to propane in presence of benzoyl peroxide. In presence of benzoyl peroxide, in the first step, what happens? Bromide will become with a free radical formation due to the free radical initiator. Means HBr in the presence of peroxide give rise to H plus and Br minus with the free radicals. In the second step, what happens? The bromide free radical formed join with the propane. Propane means we already know that it is like CH3 CH double bond CH2. Okay, methyl-ethyl component. So this will go and get attacked with the bromine. So what happens? The bromine will be forming with a major radical and a minor radicals. Like the product will be like this: CH3 CH CH2 Br. Okay. Now this is said to be secondary radical, and the next one would be methyl. Okay, dimethyl. Okay, dimethyl propane. So here we get one radical. Means you can see the radical is going to shuffle their positions with the primary and secondary. Okay, so the secondary free radical is more stable, hence it won't form easily. So addition of this hydrogen radical with a secondary free radical gives one bromopropane as a major product, and the next one would be a minor product. Okay, so the reactions are like nucleophilic substances reaction is reaction during which one nucleophilic in a component is replaced by another nucleophilic reaction. Understood? So a good example for this nucleophilic reactions are like hydrolysis of alkyl bromide, which is in the presence of basic conditions. Okay, for example, see RBr plus OH minus. So we get ROH plus Br minus. Okay, so this kind of reactions and mechanism is being seen with the Markov-Nikolov rule. And in this we have nucleophilic reactions are undergoes with the two different substituent reactions, that is unimolecular nucleophilic substituent reaction and bimolecular nucleophilic substitution reaction. Now I'll explain you about what is unimolecular nucleophilic reactions and bimolecular nucleophilic reactions in the next video. Thank you.